Okay. Say the moon just vanishes tonight. Poof, gone. What do you think happens? Most people picture the same thing. A sad, empty sky. Maybe a poem gets written. Someone's proposal photo looks a little worse. That's the image, right? A hole in the night sky, a little melancholy, nothing your body would actually notice. Forget that image. It's not even in the top 10 worst things that happen. Because within hours, the ocean itself starts acting like it's forgotten the rules it's followed for 4.5 billion years. Here's the assumption I want to go out to first, because everybody makes it. We think the moon's job is lighting up the night. That's it. Decoration. Something nice to look at, something poets latch onto, something that makes a beach at night feel romantic instead of just dark. And sure, moonlight disappearing is real, that happens. But that's cosmetic. That's the least important thing on the list, and I want you to hold that thought, because the actual disaster is invisible, and it starts in the water. Let's get the tides straight, because most people have half the picture and don't know it. You've probably heard. Moon pulls the ocean, you get a tide. Fine, that's true. But here's the part that trips people up. Why are there two tides a day, not one? If the moon's just pulling water toward itself, shouldn't there be one bulge, one high tide, and that's that? Here's the weird part. There are two bulges, one on the side of Earth facing the moon. That one makes sense. Gravity's pulling water toward it. But there's also a bulge on the exact opposite side of the planet, facing away from the moon entirely. And that one exists because of inertia. The water on the far side is basically getting left behind as the Earth gets pulled slightly toward the moon underneath it. Two bulges, opposite sides, and as the Earth spins underneath them, you get two high tides and two low tides roughly every day. That's the actual mechanism. Not a metaphor. That's really what's happening under the water right now while you're watching this. So take the moon away, and what's pulling the water anymore? The sun, technically, but the sun's gravitational pull on our tides is way weaker than the moon's, even though the sun's obviously way bigger, because tidal force cares about distance more than mass, and the sun is just too far away to compete. Kill the moon, and tidal range drops to something like a third of what we've got now. Doesn't sound catastrophic when I say it like that, does it? A third. But think about what actually depends on that rhythm. Estuaries that flood and drain on a schedule. Fish that spawn when the tide hits a certain mark. Entire coastal food chains built around water showing up and leading on time. Every day for millions of years. You cut the tidal range by 2/3, and it's not a slow fade. A lot of that system just loses the beat entirely. Mudflats that used to flood twice a day might barely flood at all. Fisheries collapse. Nesting cycles desynchronize, and that's just from the water doing less water stuff. That's the shallow problem. Here's the deep one, the one that actually keeps planetary scientists up at night, if you want the honest version. The moon doesn't just move water around, it stabilizes something way more fundamental, the tilt of the Earth's axis. Right now, we sit at about 23.5 degrees, nice and steady. And that steadiness is the entire reason we have predictable seasons. Not chaotic ones, predictable ones. Summer follows spring, follows winter, follows fall. Same order every year, because that tilt barely wobbles. And the reason it barely wobbles is that the moon's gravity is constantly, quietly correcting it, like a hand resting on a spinning top, keeping it from tipping over. Take the hand away. What happens to the top? It doesn't fall over instantly, but it starts to wobble. And the wobble gets worse, and eventually it's tumbling in ways you can't predict just by looking at how it started. That's Earth's axis without the moon, according to the models we've got. Not tomorrow, not next year. Over millions of years, that tilt could swing chaotically, by tens of degrees potentially. And a swing like that isn't a cosmetic change in season length. It's the difference between mild summers and winters that lock a hemisphere in ice, then centuries later, cook it. Climate stability, the thing that let complex life have time to evolve slowly instead of getting hammered by wild swings every few thousand years. A big chunk of that stability is coming from a rock 384,000 kilometers away that most people have never once thought about as doing anything. Now, I want to be honest with you about the actual timeline here, because it's easy to make this sound like instant apocalypse, and that's not accurate, and I don't like inaccurate drama. Tonight, if the moon vanished, nothing catastrophic happens in the first few hours. The sky just changes. Tides start shrinking, but gradually, over days, not seconds. Animals that navigate or time their behavior by moonlight get thrown off almost immediately, though. Sea turtles that use moonlight reflecting off the ocean to find their way to the water after hatching, certain fish species that spawn on lunar cycles, some birds that migrate partly by moonlight cues. All of that gets scrambled fast within that first night and the nights after. And here's something almost nobody thinks about. Nighttime gets darker than any human being alive has ever experienced. No exceptions. Moonlight has always been the backup light source for every dark night in human history. Even on a moonless night right now, you're getting some ambient scattered light, some cultural memory of what dark means, calibrated around the world that's always had a moon in rotation somewhere. Take it away permanently, and true darkness, the kind our eyes and our instincts were never built to expect as constant, takes over every single moonless night forever. Which gets me to the part of this that actually unsettles me. More than the tides, more than the tilt. Everything you can see in this scenario gets more beautiful. That's not a contradiction I'm smoothing over. It's real. A moonless sky reveals thousands more stars, because moonlight was always washing them out. You get skies clearer and richer than almost anyone alive has ever witnessed from a city, or honestly, from almost anywhere. Gorgeous. Genuinely gorgeous. And at the exact same time, everything you can't see, the orbital mechanics, the slow unraveling of tidal ecosystems, the long game of axial stability, is quietly getting more dangerous. Beauty going up, safety going down. Same event, same night, two completely opposite trajectories, and that's the kind of paradox that should make you a little suspicious of anything that just looks fine. So where did this stabilizing rock even come from? Because it's worth asking, why do we have a moon this big, this close, doing this much structural work, when plenty of planets don't get anything like it? The leading picture, and I say leading picture on purpose, because we're naming a strong hypothesis here, not reciting a certainty, is that early in Earth's history, something roughly the size of Mars slammed into it. A genuinely violent collision. Debris blasted into orbit. And over time, that debris pulled itself together into the moon we've got now. Which means the moon isn't some cosmic accessory that happened to show up nearby. It's a scar, a leftover piece of a catastrophe that just so happened to end up massive enough and close enough to spend the next 4+ billion years quietly keeping this planet's tilt from going haywire. That's a strange thing to sit with, that the disaster and the life support system are the same object. And I want to be straight with you about where our knowledge actually runs out, because pretending otherwise would be dishonest. We don't know exactly how chaotic Earth's tilt would get without the moon. The models give ranges, not a single clean number, because chaotic systems are, by definition, resistant to that kind of precise, long-range prediction. Small differences in starting conditions blow up into wildly different outcomes over millions of years, and we simply can't run the real experiment to check. We don't know precisely how fast ecosystems would collapse or adapt to a suddenly weaker tidal rhythm. Some species might shift faster than we'd guess, some slower. And here's the genuinely open one, the one astrobiologists actually argue about. We don't know for certain how necessary a big stabilizing moon is for complex life to exist anywhere else in the universe. Is a moon like ours a rare, lucky accident that most habitable worlds won't have? Or is it more common than we think? That's a live question, not a settled one. And I'd rather tell you it's unsettled than pretend I've got a tidy answer. Here's what I keep coming back to, though, the thing underneath all of this. We treat the moon like scenery, something to write songs about, something a couple looks at on a nice night and doesn't think twice about, the way you don't think twice about a wall holding up a roof until the wall's gone and the roof isn't where you left it. But that scenery has been one of the quiet conditions keeping the seasons mild, keeping the coastlines rhythmic, keeping the whole climate system stable enough for long enough that complex life had the runway it needed to become, well, you. Reading this. Nothing about your existence required you to ever know that. That's exactly what gets me about it. So I'm not going to end this with something comforting, because I don't think comfort is honest here. I want to end it with the actual unease, sitting right where it belongs. The ground under your feet tonight, the rhythm of the tide going in and out on some schedule you've never had to think about, the mildness of the seasons that let civilizations plan harvests centuries in advance, None of that was guaranteed. None of it was permanent. All of it was being quietly held in place by something 384,000 kilometers away that you never once had to think about, never had to thank, never had to notice was working. Go look at it tonight if you can. Really look at it. Because it's not decoration up there, it's infrastructure. And infrastructure, once you actually see it for what it is, never looks the same again.